tested thoroughly. Which basically means that, but your infeasible code actually will a lot of time go into your deployment. And hackers can actually use pieces of your infeasible code to construct their attack. Okay? In many of the security attacks, hackers are not writing new code. They are composing your existing code. So if you have infeasible code, a lot of infeasible code, you're basically giving a lot more material for the hacker to use. That's why infeasible code, actual code that's not called, is also harmful. Okay? Should be get rid of. You can just say, eh, nobody is going to call that piece of code. I'm going to leave it in. No, you cannot do that. If you leave that piece of code in, because that piece of code is not tested, okay? You know what? You may have a divided by zero, or you may have buffer overflow in that piece of code. Although you have no buffer overflow and no divided by zero error in any other part of your code. Guess what? If I'm a hacker, if I can trick your program to jump into that infeasible code by modifying your execution, you're toast. Because immediately I can cause a buffer overflow or divided by zero interrupt. Okay? So if you have infeasible code, piece of code, you should get rid of it. Because since it's infeasible, you're not testing that piece of code. Come on. How can you test an infeasible piece of code if it's infeasible? If you cannot reach the code, how do you test the code? If you don't test the code, high likelihood you have bug in that piece of code. That bugs can actually become material for your hacker to compose an attack program against your own. So get rid of infeasible code. And actually, the core thing is you have to use many metrics. As many metrics as you could deal with in your program to actually evaluate the quality, test quality of your program. And this metric-based testing is very common in industry, right? Actually, probably every morning you will receive an email about a daily test of your program in terms of different coverage metrics. Okay? You have coverage metrics on one side, and also you also have the list of test cases you finish or not. Failed test case, succeeded test case that's been disabled and become obsolete and so forth, and not really able to run. And all these things will appear probably in daily email to you as test report. Okay? However, who will set up these tests in the first place? You guys. Or your poor QA colleague. But now more and more, it's actually yourself. Okay? So this is our testing process. Now basically, you test to specification, you test to code. Right? In our quiz, you are doing both. You test to specification, also you test to code. You have clear specification of what we expect. That's why you are testing against the test cases given. At the same time, you're coding, you're looking at whether you have to export all the patterns or something that's not necessarily in the code, right? You're doing both at any given time. That's the right way to go. Problem with the complexity metrics is you can't rely on one single one. You need to have a lot. And you have many. The more you have, probably, just like in machine learning, the more tests, more feature you have, the smoother your decision making is, right? So essentially, if you have too few features, you're going to have a very biased decision process. Same here. Well, the other side of the coin is actually our code walkthrough and inspection. So code review leads to rapid and thorough fault detection, up to 95% reduction in maintenance cost. So code review is as effective as our execution-based testing. As effective. That's why most software development team today, you have code review. your code review. When you check any code into the trunk, main trunk, typically you would have people review your code, either in a review meeting or through comments. So if you don't have enough people comment, if you have not addressed their comment, which they actually indicate you have addressed, I got confirmed, you will not be able to check in your code. That's why you may have people who have been working 6 months, have not checked in any code yet. It's not that they haven't written any code. Maybe their job is not to write code, but if their job is to write code, then typically they are being blocked by code review. First of all, their design may be problematic. Their coding style may be problematic. They may have bugs, right? They may have features they have not implemented at all. So all these can contribute to blocking of by review. Okay? This is actually now mechanically or automatically enforced. Basically, if your code got not enough review, you cannot check them in. If you have active comment, you have not addressed, being confirmed, you cannot check it in. When all these things are all clear, you can check it in. Even if you pass all the test to specification, test to code, criteria, metrics, and everything, if you have not passed the code review, you will not be able to check in your code. Why? Because code review is as effective as your execution-based testing. Okay, you have to enforce both. But one advantage about code review is you can actually skip over. You can actually cover the whole code instead of being bogged down by one error, right? If you're running execution-based testing, one error can actually mask a lot of other errors. Once you clear that error, boom, you have 1,000 other bugs coming up, right? That wouldn't be a problem for code review. If I see a bug, I mark it as a bug. I keep going on your code and say, this is a bug too. I mean, I mark like 20 bugs, right? But in test to code, basically, if you find a test case, boom, your system crashed. Your system crashed. You wouldn't be able to do the next 100 tests anymore, right? But in review, yeah. If I see a bug, I mark the bug, write a comment, I keep going until I finish all the code. So execution-based testing, one problem is you may never finish the whole code in the test, but a review, you can always finish the code. If you have seen all the code, you've seen all the code. So if you look at different unit testing techniques, you have black box testing, glass box testing, and review. Essentially, the idea is, through literature, you can see that from very beginning of software engineering and software development, this has come to people's mind. This is an important thing. Ever since then, this is how many, 50 years ago? Yeah, people have been thinking about these things, been studying public paper and doing studies on this, because this is actually very important. This always has been an important issue in software engineering, because we actually spending way too much time testing and debugging. That is essentially a study. So code inspection is as good as glass box and black box testing. You have another way of doing software development, which is called Cleanroom. This is basically inspired by how Intel do their chip production. Basically, by every day you go into work, you are going to be vacuumed like 1,000 times and put on your bunny suit and go in there and work on your waivers, right? So essentially here is, instead of letting bugs go into your program, let you guys program and make mistakes. Actually, we'll try really hard to keep you making mistakes, from making mistakes. Then that way, the amount of testing we'll do in the later time will be less. Okay, so that's the idea. However, this line of thinking pretty much only happened to in a highly reliable software development scenario, right? Ideally for a Boeing 737 control software. In fact, that control software are probably being done the way we are doing software today. That actually is not unfortunate because they actually deserve attention like a clean room development by using formal techniques, a lot of reviews, and incremental process, incremental development. So in clean room, essentially, you are actually trying to, do a lot of inspection, a lot of formal verification to reduce the fault that go into your system in the first place. Unlike today, yeah, we'll let you program, then we'll test to get rid of bugs, so we eventually get something relatively reliable. But now solid in clean room is, let's think about every line of code thoroughly. Okay, when we put in that line of code, you three need to agree. That is the right line to put in, right? Sounds like the Boeing should be using this method, but hey, no. They probably used our method too, right? So that's why we're not using clean room altogether. Why? Or you can just get three people sit together. If you all agree on one line of code, and then we run that's one single line of code. Then if we review that 1,000 times before we actually even send it to compilation, why can't we just use clean room? Software will be a lot more reliable.
Takes too long.
Take too long, cost too high, right? So I saw a report that, so FAA, our Federal Aviation Administration, now don't have a workforce which certify Boeing's code. So that's why Boeing's code is self-certified. Basically, Boeing certified their own code is correct. Because the main reason is they're too costly, because annually to maintain a team which are able to certify Boeing's code, maintain that infrastructure and people in terms of in FAA would require $1 billion. Okay, that is just way too high a cost to take. So that's why only for highly reliable scenario, use clean room. Otherwise, you pretty much do what we do in our process. Okay, we design, we requirement, we come up with requirement design, we come up with the scenario, and the scenario basically we know these are the test cases we're going to test. We let you guys go ahead with the detailed design implementation. We come back, test to code, we test the specification. If we pass all the metrics, when the metric hit to a certain level, or we have no time left by June 7th, all right? That's time is up. You turn in your code, right? I think that will be more likely scenario for you guys. You guys have not run out of test cases. You probably have run out of time, right? Then essentially we test the time. We use metrics to prioritize what set of test cases we will run first. So essentially today we covered inspection and review. That's non-execution based testing, as equally important as execution based testing. Okay? That's why you're doing so much code review in industry. You have execution based testing, two things, testing to code. You have statement coverage, branch coverage, linear line of code coverage, basic block coverage. You have the defined use coverage. Those are metrics. You can test to code, or you test to functionality. Essentially, your use cases, your scenarios, represented by collaboration diagram and sequence diagram. Sequence diagram is actually a great way to run your test cases. Okay, that is practically how we test. I mean, that is going to be enough for me. In the test plan, these are the things you need to hit on. I'm not going to ask you to come up with the coverage metrics and targets. That will be for higher level classes. For instance, in 456, that's a very important target that you need to hit in their project. But for you guys, we just need to see you actually hit the coverage target for your use cases. And also your input data format. Okay? That will be in your test plan. Next time, on Thursday, we're going to use the more higher level, what other techniques are available for us. Basically, this is a basic thing, basically you do every time. No exception. Every time you need to do this. Okay? You need to prepare your input data by equivalent class analysis. You need to test to your use cases. You need to test your code to satisfy all the metrics coverage. Every time, no matter where you go, no matter which software company you go work for, unless it's a very lousy software company, okay? You need to do this as software developer and tester every day, okay? On Thursday, we're going to look at other methods, which we will be helpful for you. Basically, put additional, better weapons in your arsenal. Okay, these are just bare bone, minimum weapons you need to take into battle in terms of testing. Also should be in your test plan, but not those metrics. We don't require those metrics for your test plan. We just need to come up with a plan to test all the use cases and all the scenarios, and also tell us your input data format, output data format. Okay. All right. So we have 2 weeks left for our quizzes. So let's see what do we have in store today. This is a data conversion problem, and actually it's relatively straightforward today. So this is corresponding to our, basically for our equivalent class testing, testing problem we talk about today. So essentially this is Roman numerals, represented by seven symbols, right? Essentially how you convert them into integers. So basically any input you got, any combination you should be taking care of. Okay? Then you have your equivalent testing class. You have to really look at possible boundary conditions or error conditions that may cause your problem to misbehave. Right? So this is there are examples here. Show you how for this input what should be the output. And also you have to worry that if you have misplaced, for instance, if you have other things that symbols, you need to be able to differentiate them. Okay? So this is a very nice, simple specification, clear definition of input and output, clear way to specify oracle. So essentially, this is a very good example for you to look at our testing problem and also coding problem. In our in-class test, so our problem wouldn't be as elaborate and as complex as